In this question, we want to determine the vertical asymptotes for the given function. F of x is x minus 5 over x squared minus 25. Now, it turns out one of the easiest ways to determine if a function has vertical asymptotes is to use a little bit of our pre-calculus knowledge. Let's go ahead and factor the denominator. I noticed that it was a difference of squares, so it should factor into x minus 5, x plus 5. And from here, we can now fully classify what's happening around the issue points inside of the denominator. There are two possible issues that I see for the denominator. We don't want to have x equal to 5, and we also don't want x to be equal to negative 5. Those would both cause division by 0. However, notice that x minus 5 is a repeated factor. It's repeated in both the numerator and the denominator. In this case, when I go to make a table of values, it doesn't really matter what x value I choose. This particular number that we get during the evaluation is going to cancel itself out. So what happens at x is equal to 5 is we actually end up getting a hole in the function, and we should actually be able to evaluate the limit when x is equal to 5. And I'll leave that up to you to do via a table of values. Now, the other potential issue we're going to have is at negative 5. Notice here that x plus 5 is only found inside the denominator. It is not repeated as a part of the numerator. This indicates to us that as x gets closer and closer to a value of negative 5, we're going to start to get values that are really, really close to 0 here. And since it has no other factor to cancel off in the numerator, this is going to mean that our y values get really unbounded. And this is going to cause a vertical asymptote at x is equal to negative 5.